Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 2, talk about derivatives. And this will be our last lecture, lecture number 17 for the derivative to finish this unit here. So the lecture 17, we're going to talk about the linear approximations and the differentials. Okay, so let's go ahead, go to our lecture notes and start to take a look what is the linearizations here. Okay, so before I'm going to show you the definitions, and I like to show you what is linearization means, and then we'll be able to write it down. Okay, so let's assume I have a functions here, and this is my function f of x. And here I have a point here, this is A, and then I have a tangent line goes through this point, okay? So this is my tangent lines here. Now I have, let's see here, I have another values here is x here, okay? So let's say this is x here. And so in here, okay, so if you go to here, if you put this, go up here, right? So the first thing's here, this x going to touch these lines else, right? And so let's put this ones here. Let me call this is Lx. That is what is the value based on this linear function. And then in here, when I touch the real functions here, let's see here, the f of what? F of x here. Okay, so like in here, so now what is the linear approximations? So the linear approximation basically is, so for example, if you give me a value of x, I really want to know what is the value of f of x, right? So instead of, but sometimes the function of f of x is very difficult to find. So I can try to approximate that. So this is the value of the function f of x. And here, this is the function of the value what? Lx, right? So we know, like if you're getting closer, right? So if you are in very close to the A, then the Lx is here, it's a pretty good kind of estimation for the f of x here, right? So that's why we said what is a linear approximation? Okay, so that means I can, so the linear approximation of f of x is here. That means I can find the Lx is here going to be very close to the f of x. So for examples here, right? So like, if you want to, for example, if this, we're going to find examples later show you, if this is 2, if this is a 2.009 here, if x is here is a square function here, I just say square function, then I know the 2, the square is 4, right? But the 2.009, if you put the x, if you said f of x is x squared, yeah, you need to put 0.009, then you square it. So without the calculator, this may be difficult to kind of do it by hands. But, if you can find, because I know the line, the equation is pretty easy, right? So if you can find a linear line, and then your calculation probably will be a lot easier. Okay, so that's the basic concept about what we said is the linear approximations, right? Okay, so that means I can use this point, the green one, try to approximate the red one, if they are not too far away, right? If they are not too far away, then the distance is pretty, is pretty good, right? Okay, so now let's take a look here. Okay, so we know the equation of the tangent lines, right? So this Lx, okay, so let's see. So we know the Lx, we can approximate to f of x. So how do I approximate that? Okay, so we know the equation of the tangent line, all right? So in here, the tangent lines here, remember we talk about, you have the Lx here, right? So in here, we know the tangent line, the slope of the tangent line. We have doing that for the whole list units. So we know the slope of the tangent line for f of x at the x equal to a. What is that? We said we did many times. That will be the f prime what? That will be the f prime a, right? Okay, so this will be the f prime a. And then we want to find the tangent line. Right, so we did this also. We did it in the many practice in this unit about how to find the tangent line. So the tangent line, we have a point, right? So what is the, so we have the, we have the point, we have the slope, right? So first point is here, is we have the point is A. So if this is the A, then you have f of A, right? Right? Because the A is in here. And then we have what? We have X here now to this line. So what is here? This is Lx. And so this tangent line passing through these 2 points. And the slope of this tangent line, slope of the tangent line we just talked about is f prime what? F prime a, right? And we also know by the slope and, by the slope definitions here, the slope, if you have 2 points, I can make it a slope, right? So what is the slope? Slope is the rise over runs, right? So what is the runs here is x minus a, right? So what is the difference here? How much is the rise here? It will be Lx minus what? Fa here, correct? So if you think about it, this is your x1, y1, right? So this is x1, y1, this is x2, y2, right? You have the 2 points, and then it's a rise over run. So the tangent line, the derivative f prime a, then you multiply the x minus a both sides, and then you will get this is Lx minus f of a is equal to the x minus a times f prime a here. Then you add the fa both sides, so you will get x Lx equal to the f of a plus f prime a x minus a here. All right, so this is what we call is how do you find the linear approximations for the f functions here, right? Will be the f of a plus f prime a, and then depends on how far, how far the distance between the a and the x, right? So it's x minus a. Let's take a look at a few problems. I think then you will have a good understanding what that means here. Okay, so now let's take a look at the first ones here. They said f of x equal to the square roots of the x. Find the linear approximations at x equal to 4. So, okay, so the square roots of the x here, we know the square roots functions is something like that, right? So if here, this is the, okay, so if here, this is a 4, so here, right? So I'm going to find tangent lines here. Okay, so now let's take a look. So we know the f of the 4, F4 is easy, it's the square root of the 4. What is here is 2, right? Then I will take a look at the f derivatives here. So the f of x, this is x to the 1/2, correct? So the derivative will just be 1/2 x to the 1/2 minus 1, so give you negative 1/2. So this will be the 1/2, the square root of the x. And then, like in here, we say it's f prime a, right? So it's f prime 4 here. So the f prime 4, this will be 1, 2, here it's 4. So what is here is 1/4. And then we can plug into the formulas here. So that's why I know my linear approximations, it will be f of a. So what f of a is 2 plus f prime of the a, so it's 1/2, then the x minus 2 here, right? So this is my linear approximations here. That means this is the equation of this tangent lines, right? So how do you use this tangent line to estimate? Okay, so right now, how do you use these ones here? So for example, this is 4, right? So if I want to see what is the value of 4.02 here, the real value for 4.02, and if without a calculator, it's probably very difficult to find 4.02. And now let's take a look, right? So if I want to find what is the square roots. So if I want to find what is the square roots of the 4.02, think about it. Without a calculator, I don't think it's easy to do that. Okay, so now let's use the linear approximation. So I said L 4.02, right? So I want to use here 4.02 probably is someplace in these lines here, right? So I said 4.02 here is equal to what? Is equal to the 2 plus 1/4. Then here's 4.02 and minus what? I'm sorry, this is minus 4. It's x minus a, so this is minus 4. So it's 4.02 minus 4 here. Okay, then this one's here, this is 1/2 plus 1/4 0.02. Right, so the 1/2 0.02, and then this one's here, you can use a hand calculation, you can find that this is 2.005. Right, so you estimate the 2.04. So if you use the calculator, then you put the square roots of the 4.02 in your calculator. What you're going to get, you will get a 2.00499. Look how close. This is so close, right? So we know those linear approximation, special, like if you are not too far away from the point, you know the value, then the approximation will be pretty good here. Okay, so let's take a look at another ones here. So these ones here, they say, hey, let's try to find the linear approximation and at x equal to 2, see here. Okay, so for the x equal to 2, let's say, okay, so the first things that I need to know is what is f of 2. So this one's easy. So this is 5 times 2 to the cube, and so that will be 2 to the cube plus 2 times 6, right? So this is 52. And then we can take the derivative. So f of x will be 15x squared plus 6, right? So now you plug in the f prime 2 here. So what you will have here, so you will have 15 times 2 to the square plus 6. And this will be what? 66. All right. And now have this. Now I can write it. So let me write our formula we just derived for the linear approximations. Here is FA plus F prime x minus a, right? So now I know my linear approximations here will just be f of a is 52 plus 66 and x minus 2, that's right. Okay, so now this is what I do the linear approximation. That means I try to approximate the value very close to the value x equal to 2. So now let's see here. If I want to find a 1.98, okay, so now for the 1.98, so if you want, so this one's here, so you want to find the real value, you plug it into these formulas here. So it's 5 times 1.98 to the cube plus 6 times 1.98. Of course, if you put it into a calculator, it's easy. But if you don't have a calculator, it might take you a few minutes to do this cube, right? How to do the cube of 1.98. So now I find it, this one's here, this is a 50.69196. Okay, now let's see if I can use the linear approximation. Okay, so if I use the linear approximation, I'm going to find 1.98. All right. Okay, so the 1.98 based on my formula, the linear approximation we just derived. So it's 52 plus 66, right? So this is 1.98 minus 2. So this is 52 plus 66 times negative 0.02. And this is pretty easy to do by hands, right? So this will give you 50.68. All right, so now you take a look. This is the true value, and this is the estimate value. And so this, how does this, how close is this approximation? Then we say it's close to what? Close to the 0.01 ranges, right? Because this is 0.68, 0.69, so it's very good, right? So it's a very good linear approximation. That means, you know, that's why this linear approximation to help you is when you try to close to that value instead of using the function value, and then you'll be able to use the linear function. Okay, now let's take a look at this one. It's even, you know, this problem even, you know, very neat. So the number 3 is here. They say find the linear approximation of f of x, the sine x, at a equal to 0. And I want to use it to estimate pi over 15. First, the pi over 15 is not a special angle, right? Like the angle we are familiar with. So this is not special angle. So how do I, you know, if I don't have a calculator, how do I do it? Okay, so now let's say they said find the approximation, the sine at the a equal to 0. So just like we said, f of 0, let's plug in the value. So this is the sine 0 is 0. Okay, then you say let's take a look at the derivative. So the f prime x here, f of x is sine x. So what is f prime x? It's a cosine x, right? And then you plug in the f prime 0. So cosine x is 0, so it will be cosine 0. What is cosine 0? It's 1 here. Okay, so that's why we said Lx will be f0. So it's 0 plus 1 times x minus 0. So this is what? It's x. So it's kind of like makes sense, right? So here, this is my sine functions, right? So based on this linear approximation, we say how do I approximate the value of the sine when it's very close to 0? Hey, I can use these lines, right? This is y equal to the x line, or just like we derived. It's pretty cool, right? I can estimate, I can approximate the value of the sine function by using these straight lines here. Okay, so now let's take a look. How do I use the, the sine pi over 15th here? So I'm looking for pi over 15th, right? So because the sine is just y equal to x, so it's equal to the pi over 15. Then you can use 3.14159 divided by 15. And what you will get here, you will get approximately 2.2094. Okay, so this is approximation. And now, if you put this, use the calculator. Okay, so if you put the sine pi over 15, if you put it into the calculator, what is the calculator will tell you? Calculator will tell you the value is 2.79. Okay, so see here, this is the approximation, and this is the true value by using the calculator. And they are very close, right? So the good estimation, they accurate to the third decimal point. So that's pretty good, and it's pretty neat. For the sine function, you can use just like y equal to x, this straight line to estimate the value close to the zero. And then you find out the approximation is pretty close. That's very cool. Okay, so now the next thing here, we said, hey, let's try to find the what is the, without using a calculator, and how do I find the square root of the 66 here? Okay, so now I want to show you how close we are. Okay, so let's, if you plug this number into the calculator, okay, so you'll get the square root of the 66. If you put it into the calculator, you will get about 8.1240384. Okay, so this is what the calculator value. But now we don't have that. So, okay, let's assume, let's see how close my approximation is. Well, 66. So we know 66 is the square root. So which is a known value? I know the square root's value, 64. Right? So I know the value 64. Okay? So because the 64, square root of 64 is 8. Okay? So now I will say my f of x, I can say my f of x is the square root of the x. Then what? A is 64. I want to find the linear approximation close to the A, so it's 64. Okay, so let's do the typical. I plug in the value. 64 is 64, so what is here? 8. Then I'm taking the derivative. So this is 1/2, right? So this is x to the 1/2. So this will be 1/2 x 1/2 minus 1, negative 1/2. So this is 1/2 square root of x. Then I will put a f prime, what? 64. So what is f prime 164? Is 1/2. This is 64. So it's 1, 2 times 8. So what is here? 1/16. Okay, so I can write out my linear approximation. So what is my linear approximation? F of the A. So it's A plus F prime 1/16. Then the x minus 64. Now you want to find L66. Okay, so this will be L66 plus 1/16, 66 minus 64. So this is A plus 1/16 times 2. So this is A plus 1/8. I know the 1/8 is 0.125. So this is 8.125. Okay, so take a look again. It's really is amazing, right? So you use a calculator. This is a 8.124, and then you use approximation is 8.125. They are accurate till the the decimal point, till the third decimal point, right? So let's so they it's 1 2 1 2 here, right? So they're accurate to the 0.001 position. So that is a pretty good estimation, the the approximation, and make the calculations a lot easier. Okay, that's it. That is for the first video for these sections. Then the second part, the second video about this lecture, we're going to talk about the differentials here. Okay, that's it. Okay, so talk to you in our next videos here. Bye.